It's late, but we made it. No warning this week. Happy Friday. Yo, what's up, John? Happy Friday. Almost didn't make it this week. We are going to be designing a chassis. I'll give it a few minutes and see if anybody wants to hop on. Yeah, I'm good, man. My daughter had a little band concert. Just been in band camp for the last 2 weeks, so had a barbecue and then a little show. And we'll get all set up. This is what we're going to be designing a chassis for. A couple different companies make this hilt. This particular one is from Korbanth, so I'm not sure who actually makes it because they're just a Saber reseller. This might be from Elf Sabers. Not sure. Enjoy every moment of life. Yeah, I know, man. She's getting big. So, a couple people are hopping on. We might be able to go ahead and start up. This is the Saber we'll be designing a chassis for. The switchbox makes it a little tricky. I don't like doing static chassis with recharge ports, and the only place this hill opens is from the pommel. So I've been sitting on this for 2 weeks about how I was going to do it. I think I have a plan. So we're going to make a completely removable chassis. I'm going to use some of these wireless connectors for the switches and the LEDs. That's the plan anyway. So I'm going to swap my screen over to Fusion 360. And I'll try to keep my eye on comments for now. We'll just go and model up. What do we want to do here? I did take a few measurements before this, so I wouldn't be completely floundering. What's up, Vitali? This is Vitali's Saber. I was going to send it back to him because I couldn't think of a chassis, and he said, no, hang on to it until I thought of one. So here I am. I think I have an idea. We'll do. Let me get into the drawing a little bit, and then once I get some stuff in here, it might make a little bit more sense what I'm doing. Always just kind of start with the basics. So I need a battery compartment. Get that going on. Hey, what's up, Greg? What's up, Cole? We're making a chassis this week. We're not going to install Saber this week. Honestly, I'm a little installed out for a day or two. So we're going to mix it up. Just going to do the basic design first and get that out of the way. And we'll start customizing it towards this Kanan. Oh yeah, I might do things the hard way, but we'll have a chassis eventually. This is a little something I like to do. I've been doing this for a while. I will make this channel below the battery compartment so that when you're looking at it from here and you put your battery in, you don't see any wires. So that's what I'm doing right now. Getting our battery compartment out of the way. It does take a little bit. That's the way I want it to look. That's probably good. This would be the negative side, or the board will be coming off of this side. So we're going to flip over here. This Saber is going to use, it's a 1.06 inch diameter. That's the diameter that I've got to work with in the Saber. So we're going to use a 0.2 millimeter Smuggler's Outpost Nano Elite speaker. It's a mouthful. We're going to use that in this chassis because I can fully enclose it. So in my opinion, that speaker performs as good, if not better, than the 24 millimeter when you're able to fully enclose it. That's what I think. So that's what we're doing. All right, over here, grab this. There's a little trick. I used to draw these one at a time, one over here and one over here. I tried this way the other day though, and it works really well. So we'll come over here and we'll draw a line. We know this is 2.96 inches long. Whoops. 2.96. Draw a line right in the midpoint. Bring that down over here. Whoops. From here. Do that together. And this here. Do it one more time. Let me draw my line first. So we want a line here. Line here. Yo, what's up, Albert? Drawing some battery tab holders. And our mirror line is right here. That's why I put that over here. So now instead of extruding one side at a time, I do both of these and I can drop them in at the same time. So that's good enough. 0.7 inches is the minimum you want to go. That went 3/4 of an inch, so I'm good with that. But I do like to grab these sharp corners in here, double them out to keep the model strong. I don't double them too much. The fourth one, I just go like I think 0.075 is enough. So now we've got our battery compartment with our battery tab holders. That's fine. This is the side with the speaker. I know this is the side I want the speaker because I make. You can see this piece right here, a little cutout where this side doesn't have it, because I got speaker wires coming through, 2 speaker wires, 2 positive wires. All that's got to be shoved in there. So that's why I put that little thing right there. This guy right here. All right. We'll come over here and we will draw in our speaker holder. Way better than the Predator movie. I don't know about that, but thanks. Thanks, Warren. That movie was awesome. And I'll probably watch it again this weekend. So this 22mm speaker, I'm going to go 0.87. Pretty close though. What's up, Sir Peanut Butter? So we'll go 0.875. It makes me feel a little better. We'll extrude this out enough to fully enclose the speaker, which will be about enough to grab the speaker. 5 inches or 0.5 is fine. Now something about these speakers, I'll show you. You got these little nubs on each side, your solder joints, your solder tabs. So we got to account for that in the model. I've mistakenly not done that before in the whole check. So come back over here, draw a line. Thirty, yeah, that'll do. About right there. I'll take these two, we'll extrude them into the model. Now we've got space for our solder pads. So that's all done. We'll come back when it's all done and we'll make it look pretty. But for right now, I just want to make sure it's going to do what I want it to. I'll put these little things in I like to do. And this one, I want to use these to cut in the middle, so you offset them about 1 inch. drag them down till they cut in. Not too much. I'm happy with that. And we gotta go grab all these corners. Go them out just a little bit, and then I like to grab, whoops, I like to grab these two. These four right here, drag them down a bit. Oops, too much. Let's see. Play around with it to get what you want. That'll work. All right, so now we've got our speaker holder, our battery compartment. Now we need to start working our way towards the board. Of course, this is a CFX because that's the only thing Vitaly ever does. So I know I have 6.34 inches I want this chassis, this main chassis to be. So if I measure what I got now, 3.66. Got my calculator. I got another 2.68 inches to play with, so I got plenty of room. Profit equals divorce. Jesus. All right, we'll start. Now we start modeling for a CFX. So CFX is 0.82 inches wide. I like to do it anyway. I like to make it a press fit. Now 0.11 inches. That is enough of a board shelf for the board to go into the chassis. And the solder pads to not touch the inside of the hilt, as long as they're not gobbed on there. Right. About 0.1 here. Now we're going to do a little something different. I'm going to make this line here because I need some meat in this chassis. I'll explain why in a little bit, but that's good right there. Oh, nice. It's a hell of a deal, Cole. I'm taking all this. I'm going to extrude it. What are we doing here? I'm going to go, let's go 1.9. That's plenty of room. Whoops, I forgot to grab all this. Wanted all this. That too. Good Lord. There we go. A little meat in this chassis because that's where the wireless switches are going to go. They're going to come in from under here. We'll deal with that here in a second. But for right now, let's clean up this board. We could leave the shelf like this. Like if you're looking at it like this, all right, you can see where the CFX would sit here and it catches on this lip. But I don't like leaving it going all the way down to here because that's not how long the board is. So we'll clean it up a little bit. The length of the actual board is 1.36 line. Oops. There we go. Yep. Is the free version of Fusion 360 any reason to use the paid one? No, the free one will work just fine. I used it for a long time. I didn't have any issues. I ended up, I actually do pay for mine, but no, the free one would work just fine. It's not cheap either. So, I mean, if you can get away with using it, that's great. Do that. All right, let's make a little bit of a shelf here so we can't see our wiring. 0.11 is how far the board sits down, and then another 0.1. Oh, we don't need that, do we? Hang on. Trying to think of what I want to do here. We'll do it. I probably might wire the CFX with this SD card down and USB on top. And if he does that, well, then this shelf right here will be fine because you can still take the SD card out without moving the board, which is really what I try to do. What's up, Brian? You're not late, man. I'm late. Just looking at this. I'll extrude this out just a hair. I'm at 1.36. Oh, actually, I can move this as far as I want because the SD card can be reached. So we'll just bring it to this right here. I might take about another that just to be safe. So now we've got a board, or battery, or speaker. And where are we at distance wise? So currently the length of this guy is 5.56. So I have another 0.78 inches I could go. So that's perfect, right? So we'll just go ahead and we'll do that now. .78. Now if I measure this out, I actually get exactly 6.34. There we go. That's what I wanted right there. What's up, Jim? Now that we've got our basic chassis, that was the easy part, getting all that. We got to figure out the switches now. So for this, I got to take off the switch box of this lightsaber. So bear with me. One measurement I forgot to grab today. It's been a long week for Sabers. Shit. I just found it. Okay. Yes, that was the easy part. We got to make these wireless switches work now. So my thought behind that was to come from behind the board, like here. Where's it got me at? No, it's got me on top. So we're going to have to be, we're going to draw from here. What do I want to do? I want to give Vitality plenty of room for wire management. Let's see what 0.27 looks like. I'm not able to get away with that. I'm going to have to go with a 2. Maybe a 0.22. Okay. Now we want to be, let me get one of these out. Getting out my components. Point 2 is plenty of room for wiring. You'll be all right, I think. So these wireless things that I'm using, or the one that's going to be for the switches, is 0.3 inches wide. We need a little bit of room to tuck them in, so we're going to go 0.35. $1.75. How long did it take to become familiar with the software to make it do exactly what you want? Well, I've been, it was an easy jump for me to come into this because I've been doing AutoCAD work and drafting AutoCAD, all that kind of stuff since I was in high school. Very familiar with AutoCAD and SolidWorks. And this is super similar to that. So it wasn't too bad for me. My learning curve was Sabers in general. So we're going to negative 1.38 is where it starts. Grab this and throw it out a little bit more. It starts there, but it's negative 0.09 inches long. It puts me right under the board. Plenty of room there. That should work. That should work. Now we have to come over here and we need to put a blade side PCB in here. We're going to have to offset it probably. I know we will, actually. I got these blade side PCBs from Osh Park. So I'm going to throw one of these in your box, Vitality, because I'm sure you probably don't have these. And since I'm modeling it to fit this, I'll make sure you have it. These are 0.73 inch diameter. Huh. a good place for it. And the blade side PCB is 0.06 inches thick. That's where our blade side PCB is going to go. And then I'm going to use one of these also I have from Osh Park. 7-pin PC, just a simple 7-pin PCB to connect this chassis to the main pixel connector. All right. But we'll worry about that other piece in a minute. What I really want to focus on right now is the switchbox section, because once I get that all ironed out, the rest is easy. There we go. So this is actually the bottom. Like, this is going to go in the bottom of the Saber, and this will be the top right here. We need to come over here and make another component, because I do want to draw all this stuff on the same drawing so that I can see it. I always mess this part up. Let me see. I don't mess it up, but it's hard for me to do. Create components. Here we go. That's not what I want to do. A little rusty. Give me a second, I'll figure it out. A little rusty. I don't do this very much. I do this when I make like board covers and stuff, but I haven't made very many board covers. That's not the one I should have got. There we go. That's what I wanted to do. We're going to name this. I probably do a lot of this stuff the hard way. I ran in here and taught myself how to do all this. So sometimes when you teach yourself how to do stuff, you don't do it the most efficient way. Now this is our switch box. I know this can be kind of confusing, but I like it like this. I like the chassis all whited out like that, because now I can focus on the piece that I want to draw, which is the switch box piece. So we're going to extrude that. We're going to start at, we'll offset it 1.78. Oops, negative 1.78. Bring it in. Probably want to go 0.09. want to do that either. Oh, I see what I did wrong. Let's go again. I'll take this, offset it by the real number, which is negative 1.38. Come over here, we could go 1.09. Should stay within that casing. All right, that's our switch box. Now, come to our switch box. Line. Zero two. Circle it. See how quick this is. .31. So that is 0.155 here. Here. And this. And we're going to take this. .10. Negative 1.09. Oh, okay, so that's how we're going to go into the switch box. Which is fine. I'm just going to think about it for a moment. I just noticed something, so we're going to hide this and bring this back. Draw a line on this. We need a little bit more stuff there. Ooh, how far do I want to go? That's not going to work, is it? Let's try again. Oops. Now let me grab that arrow. Here. That's fine. We'll deal with that later. It's aggravating me right now. So let's hide the body. Let's look over here. Looks back like the body. Let's draw on this plane right here. This is the middle. Okay. Put these little things in here. Done 3, 4. Let's go down 1, 5, 5. This, and this. We'll mirror it because we want 2 of them. Grab this and this. We want it to be say -0.11. All right. That's what I wanted. I'm thinking, but do this different. We're going to take these boxes and going to extrude them all the way through. At the back. No, I don't want to do that either. Okay. I'll do it the hard way. That's here 2. That's here 2. 2. Sometimes this is the funnest part for me. Do other chassis. No, that's not 0.2. Okay. I'll do other chassis, other people's chassis, like goth chassis and stuff like that. But I prefer to do my own just because I like to design them. I don't know what's going on there. I guess we'll be done. This one, right up the middle. Do the same here. Sometimes when people want to complain about why chassis cost so much, as in like, $35 or whatever, which isn't that much, you can see how much work goes into them. Plus I got, you know, once this is all designed, I turn around and print it. So I'm going to cut this entire top piece out because this is the piece that will be facing up towards the switch box outside. So I don't need any of this. I don't need any of this crap here. So what are we going to do? First, we want to find out what's the distance from here to here. 0.874. That's always giving me a measurement that's not right. That's all right. Let me go here. What the heck? Where was I drawing? This. I'm going to offset. -02. Right out the back. This is our switch box. And this should work out okay. Now the pieces that go, the wireless pieces that go in the switch box are a little bit different in diameter or different in measurements than the pieces that are going in the chassis. So the easiest way to do that, line it up without having to do a lot of math, is come over here. These little tiny circles here. 0.03, that's fine. 0.03. Add these. Bring our body back. We're going to extrude those little circles, and they come all the way through. It's no biggie. Oh, see what's happening. I left myself no room. We'll do that in a second. We're going to bring the body back down. Erase the switch box. Not erase it, but just hide it. I'm going to try this again. Well, it doesn't like that at all. Okay. Okay. say this with nothing but respect and admiration. I hate you. Dude, why? What's with the hate? Okay. What's with the hate? I need about that much. How long ago? Oh, that's what happened to it. I keep erasing it. Okay. Oh, I see. It's not letting me do anything. Save this, close it down, and bring it back in. Now we'll close it. Open it back up. There we go. I needed that. I wanted my solid drawing back. Okay, so now I can come back over here and put a little bit more meat in here. I think maybe will be okay. The ghost lines were messing with my eyeballs, and I don't know how to get it back. I'm sure it's just a simple command, but I don't know how to do it, so we do it the long way. Oops. Yep, that's what I wanted right there. Just to put that little bit more material underneath. Now we can hide the body and bring open the switch box, right? Come back under and do what we were trying to do 20 minutes ago. And this is how we're going to line these up. Make sure that the chassis and switch box, switch PCBs are perfectly aligned without having to put in all that math, because that sucks. Bring that back. I'm going to extrude these. You can see them come right through the model. Zoop, just like that. Now if I were to come over here, see our little switch box place, it's going to slide right in. If we were to hide that, we should have two holes in the chassis right there. And that tells me where the two PCBs need to go. So we're making some headway. We'll come in here and start drawing up a little bit. We're going to use the flat PCBs for this. They're 0.4 long, so 0.2, 0.2 width. 0.3, 0.15. Now, to cheat, again, we can just draw a line from this circle to this circle. Another line in the midpoint. Now we can mirror this box that we just drew. We know it will be centered on that second circle. We use that midpoint line. Boom. Now we've got our two places for our PCBs on our chassis. Oops. These are -0.06, negative 0.06. These are where they're going to sit right in here. But the wire on the corners, so you got to cut some out for wire passage. Yo, what's up, Space Windu? Solo Sabers, fuck the world. We'll go 0.1. That's enough. That's enough. Let Vitali shove those wires in there a little bit and sweat it out a little. Bring that cutout right through the underside. We'll do it again for this piece right here. We'll go 0.1 here also. I can fire up these PCBs. Throw them in there, be good to go. Cram flu activated. You'll be all right. It's not that bad. And it'll be fun. I don't know if you've ever used these before, but they're really fun. You'll get a kick out of them. Because this is a 3D printed chassis, though, you know, and if I showed you my switch box, it fits right in there, right? Like there's no room. There's no tolerance whatsoever. So I think what I'm going to do is I'm going to hide this, and I'm going to open up the gap in the chassis just a hair. Oops. There we go. Just a hair, so that it's not too tight. Not super looks like Albert's mom, but you know, snug. All right. I'm wondering if I should make this also. Let's do that. I don't want it too much, or they run the risk of not aligning. Snug. Okay. So that gives me a little bit of tolerance for my print. Prints come out pretty, you know, they're pretty on point, but this is all based on fitting very well. So I want to make sure that it goes in the chassis good and it comes out well as too. You know, cut it down here. Probably take this wall back about 0.01. like that. Okay, we're pretty good there. Hearing your mom get slandered. Yeah, every week. Every week there will be one Albert's mom joke. And maybe Benji too if he doesn't wise up. Now we can go and we're gonna make this little PCB over here, or this PCB holder last, because that's pretty easy to do. But for right now, we're just going to go in. We're just going to dial in this chassis a little bit. It's functional now, but it looks kind of boring. So let's see what we can do to it. Put my usual stuff on it. All right. Drop it down here. That looks fine. Okay, we'll put Kanan Jarrus over here, huh? Should we put Blind Knight? I know that Hilt is technically not called a Blind Knight, but I think it would be cool if it said that right here. Bring it up just a hair. That looks good. We can probably put a little. Let me look at the hilt and see if what's going on the hilt. There's not a whole lot of design cues on this guy. It's got a few things we could do, maybe. Oh my god. Let's come over here and do. Kind of like to do these so that the speaker spot isn't bare. We will not grab any of the circles that are next to the solder pad cutouts because there's no room. So let's grab these. There's no right or wrong way here. Come over here. From about here to here, we can do a little something. Maybe. 1.5. So if we, half of 0.15 is 0.075. Yeah. Okay. If this makes sense to you, yeah, hell yeah. I don't mean to be blowing through this and not explaining what I'm doing. I'm trying to as much as I can, but I'm also trying to get this done. Vitali's already been pretty patient with me. I haven't touched this for a while because it was I didn't know how I was going to do it. Now that I got it in my mind, I want to get it done. So, there we go. Let's do it again. Hold down shift when you're doing all this so that you grab everything that you can. Oh, I didn't mean to grab that line. Right here. That's probably enough. We'll go ahead and erase this line so that we can grab all this. That in there. Okay. Let me think about what I want to do here. Would kind of like to do this. And over here. Circle. Line. These lines. I'll come grab that. Grab that. 2. Okay. Chelsea? Let's see. Thank you, bro. I'm glad you like it. Thank you. It shouldn't make for a terribly difficult install. It maybe looks more than what it is. I mean, you got a switch PCB that came with a Saber, so that makes everything in the control box pretty easy to do. I think I'm going to leave it at that. So we got the main one. We got our switch box. Now we need to make another thing. Make another thing. I'm always forgetting how I did it. There we go. This is going to be called the PCB holder. It's going to go here. And I told myself earlier today that this was going to be 0.4 inches. That's the PCB holder right there. All right. There's a main screw that's going to hold this in place. We need to draw that in. So we're going to draw that in right now. .16, so 0.08. 0.08. Go like right here with it. Negative 0.4. Now we've got that groove in our PCB holder. What is this? What's the diameter of this? 0.73. Okay. That's what I want, but this one's going to be for the 7-pin PCB. And so that one's going to be in there like 0.11. Okay. Okay. I want to go here. Draw this. Offset. What is 0.4 minus 0.11 is 0.29. Negative 0.29 here. And now if I were to turn on everything, you could see we got our chassis, we got our switch box, and we got a PCB holder. Those are the three components that we need. So I'm going to hide PCB holder in the switch box. Give it one more save and then start exporting these. To my desktop. So we'll do the chassis first. See you, John. Thanks for tuning in, man. I know it could be kind of boring. It could be kind of boring if you're not into chassis design. That's for damn sure. Okay, the chassis is good, so we'll shut the bike down and we'll export the switch box. Oops. Need to call that Kanan switch box. What's up, Mundo? We are designing chassis. We designed it already, but I'm going to throw it on the printer now. I'll show you guys how I put it into my slicer, and then I'll probably, after that, we can sign off for the night probably, because I'm just going to put it on the printer. And all that's left is to print it and hope it works. Should be all right. That one's done. So now we can hide the switch box and bring in the PCB holder. And we'll export that as well. I use Cura, Cole, because you probably are using Cura as well since you got an Ender. So we'll go through the Cura software real quick. I don't know if you guys saw that chassis in the Facebook groups today that was printed on its side, but that thing was ugly as hell. Okay, all three of these are good. Let's open Cura up. I use tree supports only, Cole, and tree supports that are touching the bed plate only. And it's always worked really well for me. I'll slice up this model and then I'll open up my settings and we can slowly scroll through my settings and you can see what they look like in case you want to ever go back and pause this and compare it to what you've got, if that would help. All right, let's bring in some models. We'll do the main one first. And throw it up on its side. Never print a chassis like this, by the way. That is not the right way. Print your chassis like that. Bring in the switch box. Actually, I want to move it and take a look at it. Decide which side is best to print on. We're going to print it this way. I don't want to, but we have to do it this way. Whoop. I'll rotate it straight on this way. Kind of move that a little closer. That's good. Bring in our PCB holder. Flip it. Whoop. Flip it. So now we've got all of our pieces. We've got all three pieces that we designed, right? So what my main goal when I put these on a slicer is, you see I got that lip in there for my PCB holder. I don't want that lip to be on the build plate because it will never print as nicely as it would coming up, if that makes sense, right? I'm a little stuck on the switch box. I have to do it because both sides, as you can see, like I have a lip here, so I'm going against what I just said, but then it's more important for me on the switch box that the lip on top is right because this is what's going to snap into the hole that was cut out for the switch plate. So I had to take, I had to figure out what I want most clean, and it's that top piece right there. So that's why I did that. Now I'll always put my chassis speaker side down on the build plate because if there's anything here, once it prints out, I can come out here and I can clean this with an X-Acto knife. It's not a big deal, right? I don't want to be cleaning or cutting anything where my PCB holder goes on top because, that needs to be exact. So again, I want this to be the absolute cleanest. The bottom will be clean too, but that's just like a good practice. I have a glass bed. I have a glass bed on all of my printers. so the bottoms always come out super clean. But in case you don't, if you're using stock build plate or something, you want your best side up. Okay, so we got these on here. We'll go ahead and I'll go through my settings real quick. Settings are pretty standard. I haven't really changed much of here. My infill density. Now I use 20% on PLA. If it's nylon, I'll go up to 30%. But I don't think 20. I don't think you need more than 20% in your wall thickness, whatever that is. My wall thickness is 0.8 millimeters. I think that's super fine for a chassis, regardless of all the 3-foot memes out there. So that's my quality. And we can go into my walls. I showed you my walls. I don't mess with my top and bottom at all. That is stock from what it came with on Cura. My infill, like I said, I'll just change it if it's not PLA, but 20% to me has always been a great chassis. And I printed a lot of chassis. I do like the zigzag pattern for my infill. Seems to work well with the movement of the printer. I like the strength. Printing temperature is pretty much stock for PLA. So a 200 Celsius on your nozzle and a 60 Celsius on your build plate. That's pretty standard for PLA. Every 10% buys you a foot of a drop height, clearly. Yeah. Yeah. If I ever print another chassis for that guy, I use 0 infill. And then change my business name. Speed. I don't go faster than 50 millimeters. I think 50 millimeters is a respectable speed, and I'm more concerned on print quality than I am speed anyway. Like I got this new printer and it's capable of going 250 millimeters each second. I mean, this thing flies, but I still drop it down to 50 because I like the quality of a print at that speed. Travel speed can be 150. It can be higher. Like the travel speed on my new printer is actually 550 millimeters per second. So it just like flies, it flies when it's not printing, which is fine. Cooling 100%. I'll just open all these for you so you can see and then refer to it later if you want to. Build plate adhesion. I do none. A lot of people do brims. I can't stand brims. I think if you have your printer calibrated right, you don't need a brim. It's just something that you're going to have to peel off your print when it's done, and to me, it always looks super shitty. So if you can get away with not using anything like that, you don't need a brim because your model should stick to your glass plate. If you're having trouble with your glass plate, stuff sticking, use a little bit of hairspray or a glue stick. I do have hairspray and I use it on one of my printers every so often. It's fine. It is what it is. I would much rather do that than put a brim on one of my, a brim on one of my prints. I don't use dual extrusion. I don't have dual extruders. Everything else here is all stock. All right, so we're gonna go ahead and slice it, hit preview, and see what these. I use tree supports and connected to the build plate only. Give you a chance to think. Still thinking. So it did pretty much what I would expect it to do, right? So it captured some supports in the battery compartment, which is fine. If we flip this underside, you can see there's some, it may be hard to see on the screen, but there are some supports in here, the speaker area, which I'd expect. And then because of the way that I modeled this up, it's not putting any supports over here, which I'm not like super thrilled about, because that overhang, like if I showed you this, that red overhang right there, I'm probably going to end up having to clean that up a little bit when it's done printing. But I'd rather clean it up with an X-Acto knife than to have supports that were touching my model, you know, like the base was my model and then it went up to my model, because those things make the print really messy. So I'll go ahead, you know, I'll fix that. I've done that a lot of times. It's not a huge deal, but everything else looks pretty good. This thing's going to take, you know, 5 hours and 16 minutes, and this thing's pretty accurate when it tells me 5 hours and 16 minutes. It's, you know, it's within a couple minutes. Never tried to Google Saber porn, but if I did, I imagine this video would be first on the This video, this week's live stream, is just for the nerdiest of the nerds. So if you guys have been hanging in there this whole time, like, kudos to you. You are my people. So yeah, this is all done. I'm gonna put this on the printer. Wake up in the morning, check it out, do a little test fit. Hopefully everything is right, and then send it off. But that's it, guys. I think I'm gonna sign off for tonight. I really appreciate all you guys hanging out. I appreciate you hanging out every week. I see a lot of the same names every week, so I really do appreciate the time you guys take to watch me do my thing. And I hope you all have a wonderful weekend. All right, we'll talk to you next week.